Component 3, in-class questions. Question 3, tomatoes. An important greenhouse crop. Plant growers need to control conditions and achieve high yield of tomato production. And they are determining the effect of light intensity, and that's the units watts per meter squared, on the density of stomata on the leaves. Outline a method in which the density of stomata could have been determined. Well, if you remember a leaf, and what you then did was put some nail varnish on, or sellotape, and then you peel off the sellotape or nail varnish and put that under a microscope and count the numbers. There you are, the number of stomata under a microscope in a known area. So coat leaf surface with nail varnish or sellotape. You peel that off. That's not going to get you a mark, but that's what you do. Then examine under a light microscope and count the number of stomata in a known field of view, a known area, and you can do that using stage micrometers and so on. Calculate the area, or simply stick a ruler under it and pi r squared. So that was just a bit of AO1, remembering what you did. The plants were grown in either 100 or 20, so high and low light sources. Two other environmental factors which should have been controlled. This is just controlled variables and part of your practical work. So it's always, so we're altering, the independent variable is the light. What other things affect plant growth? Things like concentration of our gases used for photosynthesis, possibly. So oxygen or CO2 might affect that. We've got all sorts of things we could have here. The pH of the soil. That's something you can, different soils have got different pHs. Wind speed, humidity, concentrations of various minerals in the soil, possibly. But that's enough for this. We have got a rather frightening data table, possibly, and here's our hypothesis. Hypothesis tested was higher the light intensity, the higher the density of stomata on the lower leaf surface. So there's high and low, and there's our two surfaces. 10 repeats, a mean and a standard deviation. Using the table below, calculate the standard deviation for the density of stomata on the lower leaf. Enter the standard deviation into the table of results above. And state your answer to 3 significant figures. Right, well, the first thing we need to do is add these numbers up. So let's do that. 4.49, 2.35, 1.54, 0.06, 0.9, 0.31, 1.17, 0.23, 1.99. So that total, so this is the total, 13.04. over the page. This is our equation. So I think that's supposed to be standard deviation. Sorry, that's supposed to be square root. And that's the formula there. So we've just done this. This is the bottom of the table. So that was our 13.04 divided by n. What's n? So that's our 13.04 for the sum of those. Our n is how many repeats? We've got 10. So that's going to be 10. So that equals square root of 13.84 divided by 10, 1.304. So that's 1.304. So square root of that is 1.141928. And remember, they wanted it to 3 significant figures. So 1, 2, 3, so 1.14. Do we need to round it up? No. So 1.14, and it said, can we put it in here? So 1.14. There we go. What information do the standard deviations in the table of results provide regarding the reliability of the results of the experiment? Right, 3 marks. We're going to say 3 separate things here. And we're going to remind ourselves what standard deviation is, and then use some of these numbers to say whether the reliability is higher or lower for those particular results. So, standard deviation. Standard deviation shows the variation from the mean. And so if we've got a high standard deviation, it shows more variation from the mean. So we've got our bell-shaped curve there. Is this, a wide curve, or is it a narrow curve around the mean? And so let's pick. So from our results here, we've got a large standard deviation there, for example. So we could say at high light intensity on the lower surface, we've got a high standard deviation, so that's less reliable. Whereas we could say, for example, the reliability is better for this number here, so high light upper surface, more reliable. And we could go down here, we could say our most reliable result is our low light and upper surface. And if we gave some numbers, that would also help as well. So this is a AO3 skill, which is, we've calculated some numbers and we're inferring the standard deviations and the reliability from there. So I'll just put a couple of those into words. So at high light, lower surface, standard deviation is 1.14, least reliable result. Least reliable mean. Where, for example, most reliable. So let's go for the most reliable. Let's go low light, upper surface, 0.04. So low light, upper surface, standard deviation equals 0.04, most reliable mean. So there's 4 of the marks you could possibly get there, and you only needed 3. To what extent do these results support the hypothesis? Well, our hypothesis was more light, more stomata on the lower leaf. So more light, stomata on the lower leaf. So we're comparing this number here with this number here. So is 8.43 bigger than 8.34? Yes, it is, but only slightly. And look at the standard deviations, so plus or minus 1.14, so that'll take that down to 7 point something and then up to 9 point something. And even this standard deviation here is quite big compared to the gap. So we're not supporting that hypothesis, and we just need to put that into numbers. So the hypothesis is not supported. There's very little difference in the means. So for example, highlight 8.43, so e.g. highlight 8.43, low light 8.34 stomata per centimeter squared. Stick the units in there. Okay, so we compared those two. We could say, we talk about the standard deviation, so the difference is much less than the standard deviation overlap. Or we're talking about the reliability of that data is not able to support that hypothesis. Based on these results, suggest an alternative hypothesis for the effect of light density on the stomata density in tomato plants. So we could say, let's have a look at this data. How about, so we got no difference there. Does light affect the upper surface? So there's the upper surface 2.91, and there's the upper surface of low light. So high light 2.91, low light 0.09 for the upper surface. So that would be a better hypothesis, wouldn't it? And the standard deviations are not going to overlap. Look at that tiny standard deviation there. So that would be a better hypothesis. So highlight. So highlight increases the stomatal density on the upper leaf compared with low light. That'd be a better hypothesis. 15 marks.